So what we're about to do is determine the domain and range of a piecewise function. We first must start by graphing the piecewise function. So take the first piece of the piecewise function, and we're going to graph. So graph y equals negative 3x plus 4, and remember that this piece of the piecewise function is only for x values that are less than 4. So create a t-table, and I'm going to pick some number that is less than 4, because that's what says the domain for this piece is, any number that's less than 4. So I pick 2, and I'm going to plug that into this piece of the piecewise function, and I'm going to solve for y. So I get y is equal to negative 2. We need at least 2 points to create this line for the piece of the piecewise function. So I'm going to pick another x value. And this time, the x value that I'm going to choose is this boundary point. So notice that for this piece of my function, x can be less than 4, but it can't actually be equal to 4. But we still choose this boundary point so we can see what is happening up till we get to the point of x equals 4. So now place the value of your boundary, in this case it's 4, into your equation and solve for y. I have y equals negative 12 plus 4, or y is equal to negative 8. So I'm going to go and put those pieces on my graph at 2 and negative 2 and 4. Oh, sorry, not there. 2 and negative 2. And then 4 and negative 8. So if you've noticed, I actually put an open circle here on 4 and negative 8 because we can't actually use that value for x. We can just get close to it. So my piecewise function looks something like this. And it should be a line. I'm just trying to freehand it, so mine isn't, but that's okay. So this is the first piece of my piecewise function. Now we're going to graph the second piece of the piecewise function. So that is y equals 3/4 x plus 5. And these are for x values that are greater than or equal to 4. So again, I'm going to make a t-table. I'm going to pick values for x and solve for y. So the first value that I'm going to pick is this boundary point, an x value of 4. So we can actually use the value of 4 for this piece of our function because it says x is allowed to be equal to 4. So plug that in. 3/4 times 4 plus 5 is equal to 3 plus 5, which is equal to 8. And I know that because my fractions were able to cancel out like this. So 3 plus 5 is equal to 8. So 4, 8 is the second piece of my piecewise function is the boundary point. And then I'm going to choose some other number for x as long as it is greater than 4. So pick a number that's greater than 4, and I'm going to choose 8. And I'm choosing 8 because it will cancel out very nicely with my fraction. So plug this in. I have 3/4 times 8, or 3/4 times 8 over 1. They can both be simplified by 4. So this becomes 3 times 2 over 1 times 1, which is 6, plus 5. I get an x value of 11. So 4, 8, and 8, 11. So go over to the 4. Now I'm going to a positive 8. I have a closed dot since I'm allowed to use the value of 4 for the second piece. And then 8, 11. 5, 6, 7, 8. Go up to 11 and connect your dots. Okay, so now for domain and range. Domain is the spread of this function. How far does it go in the x direction and in the y direction? And since we have no gaps here in the x values, if you think about the number line, this first piece says all of the x values can be less than 4. So it's talking about everything going this way. And then the second piece says x is greater than 4. So it picks up that 4 and it says everything going this way. So there's no gaps in the x values that we're allowed to use. So our domain is negative infinity to infinity. And we can also see that from the graph. So from the graph, if you'll notice that we start here, or we start over here, I guess, to the left with this piece and come in, and then we jet out towards the left. We cover the entire scope of the x-axis, so our domain is negative infinity to positive infinity. Now, the range. How low does this go to how high does it go? So looking at the bottom of our graph, this is our low point, which has an y value of negative 8. So that is the lowest number. Need to make that an 8. That is the lowest number in our range. We don't actually get to use that value of 4 for this piece of the piecewise function, and that's why we have a parenthesis next to this negative 8, meaning we can get really close to it, but it's not an actual point on our graph. And then we say, how high does this go? Well, our first piece of the piecewise function goes up towards the top. Our second piece of the piecewise function goes up towards the top. Since there are no gaps, no actual gaps in our y values, the bottom number, the lowest this graph goes, is to negative 8. And since it continues up the graph, our highest value is positive infinity.